Today, we're going to talk about what's important to quantitative traders, quants, working for fund managers in the financial markets.
The big names, the big banks, it's for managing their risks.
You really should care about this because when you're getting ready to retire, you'll be wanting to make sure that there's enough liquid cash in the piggy bank to make sure you can sip pina coladas on the beach whenever you want. Now, bankers and quants care about two things in life. The first is predictability. They like things to be stable, or at the very least, predictably unstable. Markets are definitely unstable. They'd prefer their IT to be very stable, and that's where we come in.
In this case, we are not doing the operations of the solution, and we don't want to have people working around the clock. That you guys have people working around the clock.
Now, they also care about money. The money they're investing on behalf of people like you and me in our pension funds, and the money they're spending on the IT to make all that work.
I'm Thierry Pécou. I'm the managing partner of ANEO. So Capital Fund Management. It's a fund manager founded in _91 and one of the early pioneers in quantitative investment. And they're managing their day-to-day risk, daily or end of day risk to cover and hedge their risk. That you have a lot of data, technology and research to find and backtest the right signals that can anticipate what the movements in the coming hours, days could be. And they used to do that on-prem. It's always the same story. When you're on-prem, you're sizing your infrastructure for the peaks. And then when you measure the average usage of your real infrastructure, sometimes it's under 30, under 20%. So that's where the cloud comes. A freedom perspective for the researchers to do what they want, when they want.
You know, you talk about signals. These signals could be, you know, the weather in the North American continent.
Exactly. You have, of course, economical and financial signals, because the growth in the world, the growth in the country, counts for sure. There is a lot of real life, economical and sectoral signals that you can analyze. And this is where the research comes, because you need to backtest all the ideas that come from reading, that come from mathematical studies, and then analyze. And so you can have, for example, 200 signals having different weights, and you need to backtest all these ideas against the real life that happened during the last decade, and then there is a strategy, and this is where the real power and the real strength of CFM comes. The stability of the system and the fact that everything has to work very smoothly is crucial. It's really very, very important. So that was one of the reasons, and one of the fear that the guys were having when saying, okay, I know my clusters, I've given some useful names, I love them, I can touch them. What happens when I go to the cloud? And
it's a huge trust issue.
And this trust issue has been totally overcome during the project. So that's really an achievement. And in ANEO,
seriously big deal.
Yeah, that's a big deal, because we are a good technical guys. You see Wilfried. But we have also people managing all this, the transition and the transformation piece, which means that when you change the system, you change the way you process your day-to-day job, you change the way people are behaving, and so that's a global transformation.
So I'm Wilfried Kirschenmann, CTO at ANEO. I've been working there for 12 years around HPC and optimization stuff.
You said 12 years?
Yeah.
Holy crap. Okay. I just passed my 10th anniversary at Amazon the other day, and that feels like a lifetime anyway, because it's very unusual to see a Slurm-based on-premises cluster. But on the other end of that is an AWS batch environment in the cloud. It's not unusual to see clouds happen, but to see it translating everything into a containerized environment in a serverless environment in batch, that was weird, and that kind of spooked me. So we need to talk about this.
Yeah, because the basic approach would have been to a parallel cluster using Slurm on AWS.
Slurm to Slurm, that
or
kind of just seems
even
obvious, right?
a Slurm on premises managing AWS nodes. This
Right.
would have been the classical approaches.
So what were the constraints that actually caused you to come up with a really quite a radical solution like this?
Yeah, there are two kinds of constraints. The customer wanted to change the way they interact with the production. And this is something that has been enforced by the security.
Of course.
So we wanted to really have get closer to a GitOps approach.
Right. So stability, clearly, clean code execution environment, predictable outcomes. The actual-
Repeatable one dev to the other.
And that's mainly so that the predictable bit that they need to get to, the unpredictable bit, is what the markets are going to do, and that's what the real workload.
Exactly. In this architecture, we have different parts. We have, of course, the on-prem part, which will still remain. I will explain after what it does using Slurm. We have an intermediate layer, which is another implementation of their graph scheduler. And we have, after that, the AWS batch part that is basically here just to run the containers and to orchestrate them. The graph scheduler in their environment is something we didn't want to change the way they interact with the graph. A graph for them is something very, very dynamic that can change very easily. One of the way it can change, the graph is described within a JSON file. And they want to be able to say, okay, I need to ask some nodes, I need to ask something, to add something, change something, even during the execution. And being able to cope with that means that you have some way to have a state of what has been scheduled beforehand, and what are the changes that have happened in the last upload. And to be able to have that, we couldn't rely only on the states of AWS batch. We needed to have an intermediate place where we would store the internal state of the graph.
So at least superficially on the surface, from the customer's point of view, they're interacting with the graph in exactly the way that they used to.
Yeah.
Nothing there changes.
The whole graph at the beginning, it contains different kinds of steps. Some of the steps there corresponds to data extraction and data manipulations, and this will continue to be executed on premises on the Slurm infrastructure, because all their data store are available on premises. All the other steps, there are steps related to their business intelligence. There are some machine learning algorithms, there are some simulations, there are some Monte Carlo, there are many things, but very specific business intelligence to be able to get the predictions that they want to do. The hardest thing was the fact that the specification was not completely clear at the beginning, because when we started developing the graph scheduler, we had an understanding of the requirements, and these requirements were moving along the project because we wanted them to have the same experience as they had previously to limit the change management.
How big do these workloads go when they're running? And this is presumably these things are running during a trading day.
Thousands of instances. It's used every day for their morning runs. They have runs in the morning, and it's used for that every day. And it should be running like a clock.
And that's it. Happy customers with a stable IT environment, so they can study how predictable the unstable global markets are. What's not to love?